Chemistry is very, very difficult. I mean, a lot of people complain about this, but the thing is that there's just only one way to understand chemistry, and that is understanding the basics. If you don't understand the basics of chemistry, you can never understand chemistry. So, if you're somebody who finds chemistry very difficult, I think one thing you should try to do is to go back to the basics. And one of the basics you should do well to understand is how to name compounds. And I'm just going to teach you how to name compounds in a few minutes. The first thing was doing naming compound, that in basic chemistry, compounds are usually divided into three. The number one you have is the binary compounds. Then the second one you have is the tertiary compound, and the third you have is the quaternary compound. Binary compounds are compounds containing two elements in their compound. Tertiary compounds are compounds containing three elements in their compound. How about quaternary compounds? Quaternary compounds are compounds containing four elements. Now, knowing this, these compounds are named in different ways. For example, your binary compounds are usually named with their suffix ending with IDE. Example is sodium chloride, a compound that has two elements and its suffix is ending with IDE. And then for your tertiary compounds are compounds that have three elements. So you have something like HNO3, hydrogen trioxide nitrate. This compound usually end with the suffix ATE. The third one is the quaternary compounds. This compound as well usually ends with the suffix ATE. Something like calcium hydrogen triisocarbonate. Having known this, the next thing you want to know is the oxidation state. Now, one thing you have to know when you're naming compounds is that in your periodic table you have group 1 to 8. Now, this group 1 to 8 compounds, they usually have their different oxidation states. For example, in your periodic table you have compounds that can give out all their electrons, have compounds that just need one electron to be stable, then you have compounds that are in the middle. So these compounds are usually named in different ways. For example, for compounds involving those kind of compounds where they either give out all their electrons or just need one electron to be stable, these compounds are usually very easy to name. You don't need to have their oxidation state added to the compound when naming them. Let me explain. So let's do this naming this compound NO2. Now, what I want you to know in naming compounds is that these compounds that are between group 4 to group 6 are bound to have different oxidation states in their compounds, their respective compounds, and I'm going to show you how. Now, first thing, like I said, you do when you see a compound is to count how many elements are in that compound. So for this particular element, we have 1 and 2. So we know that this element is going to end with the suffix IDE, and remember it's a binary compound. So the next thing I want to do is to calculate the oxidation state of nitrogen, because nitrogen is a group 5 element and is bound to have a different oxidation state in this compound. Now, there's a shortcut I always give to my students when trying to find oxidation number. And that is the formula subscript times oxidation number. So apparently, what do I mean? For NO2, what's the subscript here? It's 1. And in chemistry, we don't write 1. So yeah, that's why you're not seeing it there. So the subscript in nitrogen is 1. What's the oxidation state of nitrogen? We don't know. We are looking for the oxidation state of nitrogen. So we're going to call nitrogen X. So this is 1 times X. What's the subscript here? This is 2. What's the oxidation state of oxygen? It's -2. So this is a neutral compound. What neutral compounds? Neutral compounds are compounds that do not have a charge. It's not a cation, it's not an anion. They don't have charges, just like this one. So you meet this kind of compounds without charges. We equate every single thing to 0, right? So having do this, you just do the simple equation. 1 times x is x. 2 times -2, it's -4. -4 times plus is okay. If I just put this here, equal to 0. So this is x -4 equal to 0. Then you have x equal to 4. Now, same nitrogen, we're going to do N2O, right? The laughing gas. So how do you calculate this? Use the same formula. You say subscript times oxidation state. Here, nitrogen is also x. Plus subscript is 1. Oxidation state is -2. Remember that oxygen, the oxidation state of oxygen is -2. Aside when it's found in peroxide, where you have your oxygen as -1. So you have 2 times x is 2x plus 1 times -2. Don't forget to equate to 0. plus 1 times minus 2, it's minus 2 equal to 0. So what we're going to have here is 2x minus 2 equal to 0, 2x equal to 2, x is equal to 1. So I'm going to name this compound as nitrogen. That's nitrogen 1 oxide. Now when you hear 1, don't come and put 1 here. How you're going to represent this is with normal Roman numerals. So 1 is going to be I, 2 is going to be II, 3 is going to be II, 4 is going to be I with just your Roman numeral. So the next one we want to calculate is this NO. Now remember our formula, subscript times oxidation state, right? So subscript of nitrogen here, it's 1. Oxidation state of nitrogen, it's unknown, so we call it X. Subscript of oxygen here, it's 1. Oxidation state of oxygen here is minus 2, and we equate this to 0. So we have 1 times X is X, plus 1 times minus 2, it's minus 2 equal to 0. The next thing we have is to open the brackets. This is X minus 2 equal to 0, and this is X equal to plus 2. Now how am I going to name this compound? Nitrogen 2 oxide. Now you've seen that in this is same nitrogen, right? Here the oxidation state of nitrogen is 4, here it is 1, and here it is 2. So when you see compounds in group 4, group 5, group 6, their oxidation states are bound to change in compounds. Now what I want you to do for me is to calculate the oxidation state of carbon in CO and CO2, oxidation state of sulfur in SO2 and in SO3. Give me your answer in the comment section.